Hello, we're going to be talking about how to use your graphing calculator to enter data and to graph and all sorts of things. So to start off with, this is the goal of the video. First of all, you're going to learn how to enter two variable data, which is really just ordered pairs, into your calculator. Secondly, you're going to learn how to graph them and see the actual dots. It's called a scatter plot. Third, if the dots happen to line up in a fairly linear fashion, then we will also tell the calculator to calculate what we call the best fit line, or the least squares regression line. It's a line that fits the data the very best. And then we're also going to write and interpret the equation once the calculator produces it for us, and we'll have to interpret that in context of whatever story we're dealing with. And finally, we will find the correlation coefficient, which is a way to measure how strong and what direction the linear relationship is. So let's get our calculators out, and the first thing you want to do is click on the Stat button, which should give you this menu, and then click on Edit, or just Enter at this point. And you should see the place where all the lists are in the calculator. We are going to enter some data that I have gotten from my stats classes, which is the height of students and the weight of students. So we've got height data and weight data. Now, just an FYI, if you have data already in your calculator from some other activity, one of the quickest ways to get rid of the data in an entire list is to move your cursor to the very top where it says L3 or L2 or L1, and then press two buttons. Hit the Clear button followed by the Enter button, and that's the quick way to get rid of all the data while preserving the list. The list is still there and you can type data in. So if you have data in there, that's the quick way to get rid of data. You also can just do delete, 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 and do it on a per data basis. So what I would like you to do, and pause the video if you need to, I would like you to type in these 7 numbers for list 1. These are heights in inches, and type in the 7 weights in pounds. Pause the video if you need to so that you can catch up. Once the data is in your calculator, the first thing you should always do is look at it and see what kind of a shape it is. So for that, we're going to do what's called a stat plot. Stat plot is the second function of the y=2 key. So hit the second button followed by y=2, and you'll see 3 different plots that are possible. We just want one of them on, so we will select number 1. And when you go into plot number 1, there's some things you have to do. First of all, you want to turn it on. Secondly, we want to pick the first graph option out of the 6. That's a scatter plot that will show you ordered pairs. And thirdly, you want to make sure that your X list and Y list are in fact the 2 lists where your X data and Y data are. So I typically just use list 1 and list 2. If you need to change that, you'll notice list 1 and list 2 are the second functions of your 1 and 2 keys. So if you need to, let's say if we wanted to type, I will just type over this. If I want to type a list 1 right there, I would hit the second button followed by the 1 key, and it would type list 1. You also can pick 3 different sizes of marks. I will pick the large one just so I can see them easily, because there's only 7 ordered pairs. So the stat plot is set up to plot correctly. The last thing we do then before we see a scatter plot is to click zoom followed by 9. There's a special zoom just for statistics. It's called zoom stat, and it happens to be zoom 9, so you can do that directly, or you can scroll down and hit it. And of course I always scroll too fast. You could just type 9 at this point, but I wanted to show you what it looked like. So zoom number 9 is zoom stat. So I can just hit the 9 key, and there it is. There's the data. The window has been automatically resized so you can see all 7 points. So the data does appear to be fairly linear. In other words, it appears that the higher somebody is, height-wise, the taller somebody is, the more they weigh, and that relationship does seem to be fairly linear. It's hard to tell with only 7 points, but it looks like it's linear. So if we would operate under the assumption that this is a linear relationship, now we want to do a calculation and have the calculator fit the best line possible. So again, we go back to our stat button, but this time we want to calculate something. So you arrow to the right 1 space, and that takes you to the calculation menu. And you can see there's a lot of things that you can do. Number 4 is a linear regression. 5 is a quadratic regression. 6 is a cubic regression. 7 is a quartic regression. And 8 is another linear regression, and so we have a choice between option 4 and option 8. And it turns out that in the future, in the near future, the letter B will be used for slope of an equation, especially in statistics. So therefore, we want to get in the habit of using option 8. A is going to be the y-intercept, and we'll just have to get used to that switch. And if you select number 8 then, the calculator will blink at you, or some of you have a new operating system that will give you another menu that you have to fill in some blanks. And what we want to tell the calculator if you're using this operating system is the X list is list 1. And in my world, I have to put a comma in there. If you have a new operating system, it'll just be another line. The Y list is list 2. And then there's some sort of a line, I believe, in the new operating system that says regression equation. And where the question is, where do you want to put that equation? Well, typically we just want to put it into Y1. Y1 is a little hard to find. It's 4 steps. You have to press the vars button, followed by the right arrow, so we go over to Y vars, followed by function, which is just number 1. You could just hit enter, followed by, again, number 1. There's Y1. It takes 4 buttons to get Y1 selected. So in either operating system, you should have told the calculator that you want list 1 and list 2 to be your X and Y data, and then the regression equation is going to go into Y1. When you hit enter, the calculator will automatically produce the slope and the y-intercept for you. And just as a reminder, remember A is the y-intercept, A is negative 162.68, and B is 4.87. That'll be our slope, or the rate of change. Now, there are 2 other things that we would like to calculate with this, and one would be correlation. And correlation is designated by the letter R, and the letter R is solely in statistics for correlation. It will not stand for anything else. So when you see R, it stands for correlation. And correlation tells you the strength of the linear relationship. So we need to find R. Before we do that, I think I'm going to write down this equation just so I have it here. So we know that in our equation, y was equal to a y-intercept of negative 1 let me start over. It's going to be y equals negative 162.7 plus 4.9x. I'm just going to leave that on my screen because I'm going to go to a different spot. Now, what we want to do is go to the catalog, which is the second function, followed by the 0 key. Notice it says catalog down there, and this takes us to the catalog of all possible operations. We want to go down to the D's. You can press alphabet D. There's an alphabet D button right here to go quickly to the D's, and we want to scroll down to something called diagnostic on. There's something that from the factory is not turned on by the Texas Instruments company for some reason, so we want to select diagnostic on and hit enter. And it doesn't look like it did much, but now the next time that we do that calculation for the line, we are now going to get R. Now a quick way to bring that command in again is to do the second button followed by enter. Do it again, second button followed by enter, and what it's doing is it's kind of going up to the previous calculations, and notice that previous calculation is still in the queue, so it brings it back so we don't have to type it in from scratch. If we hit enter, notice what happens. Not only do we get the slope and the y-intercept once again, but now we have r squared and r. R in particular is important, and so we will write down that, in fact I think I'll write down that equation again just so I have it. So y is equal to negative 162.7 plus 4.9x. And then R, the correlation was 0.81. So those are the 2 big facts that we pull out of this calculation. So if you remember how we set this up, the Y were the weights. And so the weight of people, the way this was set up, the weight in pounds, according to this equation, is always negative 162.7 plus 4.9 times the height. This is the way we would interpret this to the story, because our inputs, or the x values, were heights in inches, and the outputs were the weights in pounds. And so this is the contextual answer. And then one more thing we want to do is we need to remember we're going to put a little hat symbol. And this little hat thing always means predicted. And so if I can kind of give you a bird's eye view of what we're doing here, we just took some data from the real world. And it was kind of messy. It wasn't perfectly linear. And we decided that it was close enough to linear that we could come up with a mathematical model. That's what this is. We can call this thing right here, this is a mathematical model. And that mathematical model was doing its best job of estimating the relationship in the real world, which is the statistics component. So this mathematical model is estimating what the relationship is between weight and height. And it's saying that, in general, the weight of someone that would be in this data set can be predicted by using this equation on height, more or less, roughly. It's not going to be a perfect predictor, but it's more or less true that somebody's weight can be predicted by using this equation. It's not going to be totally perfect. That's why we use a predicted symbol. And so that's the equation that we would write down. We would use words for context, and we would use a hat over the weight to indicate that it's just an estimate, because this is just a math model that only approximates the reality of the real heights and weights of the people that were in the data set. So the math model is always just an approximation of reality. And then the last thing with correlation, you'll learn this from class and from the textbook, but correlation is a measurement on a scale of -1 to 0 to +1 of how strong a linear relationship is. 1 would be perfect in a positive sense. -1 would be perfect in a negative sense. 0 means there's no linear relationship. And then kind of in between here, you've got, strong would be anything that's kind of on this end. And then moderate would be kind of somewhere in here. And then weak would probably be somewhere in here. There's kind of a rough idea that anytime you get around 0.8, you're kind of getting into that moderate range, and anytime you get below 0.5, you're getting into the weak range. So that's kind of a rule of thumb that we use just to kind of ballpark kind of where we are in these different places. And it gives you some sense then that 0.81, well, that's kind of in the moderate to strong category. So we would say that there's a moderately strong relationship that's linear between the height and weight of these people or this group that we're looking at. So there you go. There's just a quick overview of how to use your graphing calculator to do some scatter plots and to calculate a linear regression line that fits data and correlation. So hopefully you caught that. And now you should be able to do the example on viscosity that's in that section. And you should be able to do, of course, any homework that would involve linear data. So good luck. Let me know if you have any questions.